This is the second video, and you guys don't have these questions. These are just more questions that I came up with by looking at the test and just mirroring them. Okay, I changed some graphs, changed some values, but if you understand this, you should be ready for the test. So, which relation is a function? Is this a function? Yes. Is this a function? Yes. Yes, both of them are functions, right? Why? Because they pass the vertical line test. If you draw a vertical line, it only touches once. If you draw a vertical line, it only touches once, right? Same thing over here. Draw a vertical line, it touches once. Draw a vertical line, touches once. Now, if you have something like this, like let's say you had this graph right here, then that's not a function, that's just a relation. Why? Because if you draw a vertical line, it touches 1, 2, 3. So if it touches more than once, it fails the vertical line test, which means it's a relation. If it only touches once, it is a function. So this one's a function, this one's a function, this one that I just drew is a relation. Too easy to mess up on tomorrow's final. Number 8, I was looking at this write the expression given the phrase problem on the final, and I saw how some students could get confused. So what I did was I took one problem and I created two out of it. Let's do this. Let's write an algebraic expression for 2 times x squared minus 3 times x. Okay, if I want to write 2 times x squared, I'm going to actually start by writing 2 times x squared. X squared is simply x to the second power. And then minus 3, minus 3 times x. 3 times x, that's just 3x. And that is the algebraic expression for 2 times x squared minus 3 times x. Very simple, very straightforward. If you look at this one over here, let's compare this top one to this bottom one. The bottom one says 2 times the difference of x squared. Okay, so on the bottom one you would say 2 times, that's 2 times, but when you say the difference of x squared and 3 times x, then that's in parentheses. So it's 2 times, the difference is minus, and what are we subtracting? We're subtracting x squared and 3 times x. So x squared would be x squared in there, and then 3 times x would be 3x. So that word difference really does make a difference compared to this first algebraic expression and the second. I hope that helps you guys. Any questions on that? No? Would you guys like to try this one? Or just watch me explain it? You plug in, right? So let's first start by rewriting everything exactly the way it is. So notice I have a 6 times f, but I want to put 6 times parentheses. Then minus 3 times g minus 3 times parentheses. And then I'm going to plug in my f value of negative 7. So negative 7 goes right in there. And I'm going to plug my g value of 2 right into the g position, which is 2 right there. So 6 times negative 7, what's that? When I start working on the inside of the absolute value. That's minus 42, and we have negative 3 times 2, or 3 times 2, that's 6 with the minus sign in the front. So we still have the absolute value on it. We still have a plus 7 on the outside. On the inside of the absolute value, we have negative 42 minus 6. That becomes negative 48. We still have the absolute value of negative 48 plus 7. So the absolute value of negative 48 is positive 48. And then plus 7. And 48 plus 7, that is 55. Looking at number 10 here. Another evaluating problem. Again, what do? Plug it in. I recommend writing parentheses instead of the variables. Instead of a squared, put parentheses squared. Instead of plus ABC, put parentheses, parentheses, parentheses. Then plug in your values. 3, 3, 5, 2. You're going to do exponents first. 3 squared is 9. And before adding, I want to keep the plus sign. Before adding, you're going to have to multiply these guys. So first we did exponents. Now let's do multiplying. 3 times 5 is 15. 15 times 2 is 30. And the adding you're going to do at the very end. Once again, we did exponents first. We got 9. We did multiplication next. We got 30. At the very end, we're going to add. So yes, we get 39. as our final answer. This one's so easy that some people are going to miss it. What do I do to solve that? So what do? Subtract 9, minus 9. What I do to one side, I do to the other side. What do I have next? What's negative 17 minus 9? Negative 26. Greater than W. You're not going to see that on your multiple choice, though.
You're going to see W less.
You're going to see W is less than negative 26. Okay, this is the answer, but you have to literally pick it up and switch. Put the W on this side and the 26 on that side. Now, when you switch it, since this is the answer, notice it is opening up to the negative 26. This is the correct answer. It has to continue opening up to the negative 26. So when you switch everything, when you switch this whole thing, yeah, the W goes over here, the negative 26 over there, but you have to keep the same respect. If it's opening up to the negative 26, it has to continue opening up to the 26. So if you switched everything, you have to switch that inequality as well. Don't mess up on that easy one. Number 12, another easy one. A lot of people just mess up on. What do I do there?
Multiply 6.
You don't want the fraction? Multiply by 6. Multiply by 6. You could have done negative 6 and gotten rid of two things at once. I'm just going to go with 6. You're going to have negative 5k equals 144. I hope. Is that right? Anybody? And of course, you're able to use a calculator tomorrow, not cell phones though. So our final step here would be to divide by negative 5, divide by negative 5. And this is not going to work out. I just randomly made this problem, I'm sorry. So this cancels. We're going to end up with k equals, it is positive 144 over positive 5, though a negative divided by a negative is a positive. I believe on tomorrow's test, this will work out where you can divide it and get a final answer. But if you can't, it's just going to be the fraction. All right, number 13, write an f of x equation that describes the below relationship. Now, there's many ways of doing this. If we look at the XY table, we really have an input-output table. That means I plug in a 1, I get out a 5. I plug in a 2, I get out a 7. So I'm going to try to teach you different ways of solving this, right? If you plugged in a 1 and you got out a 5, could somebody give me a function that at least does that? Like, is my function x plus 4? Maybe, right? But if I go 2 plus 4, that doesn't give me 7. Does that make sense? Okay, so it's not just adding. And if I go 1 times 5, that gives me 5, but 2 times 5 is not 7. So could somebody give me an equation just by thinking about it on what I could do to the first term, maybe with multiplying and adding or multiplying and subtracting combined to change this 1 to a 5? In other words, could it be, here's a good guess, y equals 3x minus 1, right? That might work because 1 times 3, oh no, that didn't work. Times 2 plus 3? All right, let's try that because mine didn't work in the first place. So times 2 plus 3. So what you're saying is 2 times x plus 3. Let's see if it works. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. 3 times 2 is 6, plus 3 is 9. So that works. So, good job, Raul. This is the correct equation, but it's going to be written like this. F of x equals 2x plus 3. Now, the answers are going to be there, so there's only going to be 4 answers. So you could actually just look at the answers and start testing and see which one works. Okay? Now, if you didn't have multiple choice answers, what you're supposed to do is, okay, call this your first point, call this your second point, and then do the slope formula, right? y2 minus y1 over x2 minus x1. And then once you get your m value, then you plug in your x, your y, and your m to find the b. And then you'd be able to write your equation y equals mx plus b, which would be that one. But the shortcut is to just look at your answers and test your x and y values, your inputs and outputs. So do you guys want me to work this out the long way? Or okay. Number 14, another old school problem from the beginning of the semester, solving equations. You need to simplify first, and then get the letter by itself on one side. So you either pick the left side or the right side. Don't do both at the same time. I want to do the left side first. So I'm going to erase, or not erase, I'm just going to put a rectangle over that right side so I don't worry about it for now. Let's distribute 3 times a, that's 3a, 3 times negative 5, that's negative 15. Bring down the plus 9, and then combine like terms. The negative 15 and the plus 9, what do I get? Negative 6. So we have a 3a minus 6, and that's all we could do on the left side. Now let's look at the right side. On the right side, is there any distributed property? Is there any combining like terms? Yes, so let's combine like terms. There is no distributed property. So we have negative 2 minus 4. What's negative 2 minus 4? Negative 6. So what do I have on the right side of this equal sign? What do I have? 3a minus 6. Now, ladies and gentlemen, we have the same exact variable expression on both sides of this equal sign. 3a minus 6 is always going to equal 3a minus 6. So right there what we would say is that the answer is all real numbers. I mean, you could continue going and say, okay, I want to get my a to the left side. I want to get rid of this 3a. So if you did subtract 3a, it would cancel, and you subtract 3a, the a's are gone. You have negative 6 equals negative 6. That's always true. So if it's always true, it's going to be all real numbers. If you end up with something impossible, like negative 6 equals positive 6, then you would say no solution. And I'm not saying that your answer is going to be all real. It might be no solution. It all depends. But you need to know these special cases. If it's always true, it's all real numbers. If it's impossible, you say no solution. So we're about out of time for this video, at least.